guess just tell us who you are first, and you know.
Okay, I'm Ian Pritchett.
You can probably look at me. Just
Yes.
Yeah.
I'm Ian Pritchett. I'm the Chairman and Technical Director of Lime Technology, based in the UK.
So why are you here?
I'm here because this is a fantastic day. It's the start of the first Hemcrete house in the US.
So is that a big deal?
A very big deal. Very, very big deal. This is making history, and this is not just an ordinary house, is it? This is going to be the first passive Hemcrete house in the world. It's going to be off the scale for lead points. This is a really significant project on a global scale.
So what is Hemcrete?
Hemcrete is a biocomposite building material. So it's a mixture of a lime-based binder, a formulated lime that we make, and we mix that with the woody core of the hemp plant, which is called shiv in England, and it's called hurd over here. And we mix the two things together, the binder and the shiv and water, and it makes like an organic concrete, a very lightweight insulating concrete, and also carbon negative because it's got lots of carbon locked up within the hemp.
So what's this whole thing about vapor permeability?
Yep, this is a breathing wall structure. Now when we say breathing, we mean it deals with moisture vapor, because moisture vapor can pass into it, can stay in it, come back out, or it can pass right the way through. So the way buildings deal with moisture is really important, because that creates a healthy building if it deals well with moisture. And it becomes even more important when you're dealing with a really airtight building like this one, because it's high performance energy wise, it's very airtight, so it doesn't lose energy. So the walls help control the humidity in the building and give you that comfortable and healthy internal environment. And that's what we mean when we're talking about breathable buildings and vapor permeability.
And can you describe the thermal properties of Hemcrete?
Yes. Hemcrete is incredibly good thermally. It's a very, very good insulator, but it also has both thermal mass and thermal inertia. Now, thermal mass is what we associate with big, heavy buildings that are made out of things like concrete. They have the ability to store heat, but most insulators have very low thermal mass, and most high thermal mass materials are very poor insulators. But this has a good combination of the two, because it's got a density of about, in metric, it's 275 kilos per cubic meter. So that's what, 20 pounds per cubic foot?
9 pounds.
That has a density of about 9 pounds per cubic foot, which is pretty good for an insulating material. And that means that it changes temperature really, really slowly. So the outside temperature can be going up and down from day and night, but that temperature change only comes part way through the wall. The inside won't change at all. So you've got this ironing out of the day and night peaks and troughs of temperature. And that combination of good thermal insulation with thermal inertia is what makes Hemcrete pretty unique in the world of building materials.
So why do we have to use hemp?
Well, there's a tradition of using hemp for this type of material in Europe, and it goes back a few hundred years in places like Poland and Austria, and it's been going for about 25 years in France for new buildings. And maybe in the future we'll find that there are other materials that do the same, but there's a lot of work being done on the performance of hemp, and therefore we have tests. We can predict when you're designing a house like this and you want a high R value, you've got all the data available to be able to say what the R value is going to be. You can satisfy the structural engineers that it's going to work. So it's all about having sufficient data, and all of that data has so far been acquired on hemp. So at the moment, hemp is the front runner.
But isn't it then, if we're having to ship this in from England and we're trying to be carbon negative, aren't we adding a footprint from the transportation?
Yes, certainly the carbon footprint of the transport means it's not quite as carbon negative here as it is in England. But actually shipping's not so bad from a carbon point of view, and it's still a carbon negative material. But what you're doing here is paving the way for things that will happen in the future in the US. When we first started using this in England, we had to ship it in from France. We now manufacture it all in England, and you're one of the pioneers that will lead to production here in the US. and then it will be really carbon negative.
So then what are the plans to produce here?
Well, as we get more and more demonstration buildings built, and we can start to figure out where the best places are, what the size of the market is, we can start to formulate a plan whereby we can raise the capital needed to build a processing plant for hemp. Whether that's in the US depends whether or not it's legal to grow hemp by that time. Otherwise, it will be in Canada, and we can build a plant to blend the lime, and then it's a bit of a chicken and egg. You need some pioneering projects to start to establish the market, then you follow that with the factories to make the materials, and that brings the cost down, and then you can start to get more projects and more mainstream use of the material.
And how do you finish this?
On the inside, it can be finished with a plaster, which can be either lime-based plaster or a clay plaster. And then on the outside, we finish it with a render or a stucco, which is lime-based because it also needs to be breathable. That vapor permeability extends right through the wall. So most people think that building is all about keeping moisture out of buildings. In fact, moisture always finds its way into buildings, and good building is about making sure it escapes safely without causing any damage. Bad building is about trying to stop it getting in, and then when it gets in, it can't get out, and then it causes problems later on.
He sounds just like me, doesn't he? What was I thinking? So how long do you think this wall can last? What's the life expectancy?
Well, the life expectancy depends on what the mechanisms are that would cause it to fail. And the only thing that's going to cause this to fail is water. So if it becomes saturated for a very long period of time, a bit like timber, it could start to break down. But as long as this house has a proper roof on it and the render on the outside, this wall will last forever.
Wow. Okay.
Literally forever.
Wow. And
we offer a money-back guarantee. If it doesn't last forever, you come back and we'll give you your money back.
And so let's say we do tear this building down.
Yep.
What can we do with the hempcrete?
Very good question. There are two things you can do. One is you crush it up and you mix some more lime binder with it and cast it into another wall, or you can just crush it up, spread it back on the fields, because the organic material, the hemp, will break down and add to the organic material in the soil, and the lime will improve the pH of the soil. So both of the constituents of this are things that farmers spread on the field to improve productivity. So, of course, at that time the hemp will break down and its carbon will be released back to the atmosphere, but you then grow another crop of hemp in the field which takes the carbon back in again, and it carries on in a cycle. But there's no need to knock this house down. This will be here for hundreds of years. And in hundreds of years, people will come and see this and they'll say, this was the first passive hemcrete house in the world. And those crazy guys did a fantastic job.
Those wacky doctors of building science. Let's see if that was a